All right, let's dive into some of the most powerful ideas in software design. We're talking about advanced object-oriented principles that can take your code from feeling fragile to being truly robust. Let's get right into it. You know the feeling, right? You've written code, it works, all the tests are green, but you're kind of scared to touch it. Every time a new feature request comes in, you hold your breath because you know one tiny change could bring the whole thing tumbling down. If that sounds a little too familiar, then you are in exactly the right place. We're going to figure out how to build software that's not just working, but is flexible and can handle change. So, how do we get there? We're going to walk through 5 core principles that will be our guide. We'll talk about why a class should only have one reason to change, how to make inheritance behave itself, why depending on abstractions is a game changer, how to slim down your interfaces, and finally, a simple rule for how your objects should talk to each other. Ah, yes, this is a classic. It feels so efficient at first, right? Just put everything that's kind of related to a user in one place. But this is a trap. You've just created what's often called a God class, a class that knows too much and does way too much. And the solution to this is the very first principle, the Single Responsibility Principle, or SRP. The idea is actually super simple. A class should have one and only one reason to change. Think about it. If you have to open up a class to change a business rule, and then you have to open up that same class to change how it talks to the database, well, that's a huge red flag that it's doing more than one job. So look at the difference here. On the left, you've got that God class. A single change to how you save data could accidentally break your password validation logic. But on the right, when we apply SRP, we get these nice, focused classes. Now, if the database logic needs to change, you only touch the user DB class. That separation is what makes your code safer and so much easier to maintain. Okay, this one seems so logical, doesn't it? I mean, in geometry, a square is a rectangle. It just has a special rule about its sides. So making it inherit seems like the most obvious thing in the world. But this is where we can get into some really subtle, really nasty bugs. And to avoid those bugs, we need to understand the Liskov substitution principle, or LSP. Now, that sounds pretty academic, but all it really means is this. You should be able to use any child class in place of its parent class without things blowing up or acting weird. It has to honor the parent's contract, its expected behavior. So let's break this down. Imagine you have a function, and all it knows is that it's getting a rectangle. It assumes it can set the width to 10, and the height will stay whatever it was. But what happens if you pass in a square object? Well, for it to remain a square, when you set the width, the height has to change too. And that's the problem. That's an unexpected side effect that breaks the function's logic. So a square can't be safely substituted for a rectangle, and that violates LSP. Is it brittle? Oh, absolutely. When you do that, you're basically welding your high-level business rules directly to the low-level details. So what happens when you want to switch from, say, a SQL database to a NoSQL one? You have to perform major surgery on your most important code. That's a recipe for disaster. We break that rigid connection using the dependency inversion principle, or DIP. The key idea here is to literally invert the dependency. Instead of your important high-level code depending on the nitty-gritty details, both your high-level code and your low-level code should depend on a shared middleman, an abstraction, like an interface. This decouples everything. And this is what that brittle, tightly coupled world looks like. Your core business logic is completely tied up with the database module. They're stuck together. A change in one forces a change in the other. It's inflexible and really risky. But if we introduce an abstraction, like a data storage interface, we break that chain. The high-level module only knows how to talk to the interface. It has no idea what's on the other side, and the database module just promises to implement that interface. Now you can swap out the database anytime you want, and your high-level code never has to change. That's freedom. Okay, so we're using abstractions, which is great, but what happens when the abstraction itself becomes the problem? You've just described what's called a fat interface. You're forcing this poor little simple text class, which only cares about printing, to know about things like faxing and emailing, things it can't even do. We fix this with the interface segregation principle, ISP. And it's another simple one. Don't force clients to depend on methods they don't use. It's way better to have a bunch of small, specific interfaces than one giant do-it-all interface. So with that fat interface on the left, our simple text class has to implement methods for fax and email, probably with empty code blocks, which is just messy. But by segregating them, like on the right, our class can just implement iPrintable. That's it. The code is cleaner, it's more honest, and its purpose is crystal clear.
Oh yeah, that feeling in your gut is 100% correct. That code might technically work, but it's creating a super fragile chain of dependencies. That one line of code has to know about the internal structure of the user object, the order object, and the line item object. It's a house of cards all on its own.
This is a violation of the principle of least knowledge, also known by the much cooler name, the law of Demeter. The rule is simple and sounds like something your parents might have told you. Only talk to your immediate friends. Don't reach through your friends to talk to their friends. In code terms, don't talk to strangers.
See, this line of code is just nosy. It knows too much. It knows a user has an order has line items, and a line item has a price. If any part of that chain ever changes in the future, poof, your code breaks. The much better way is to just ask the user object for the information you actually need. Let the user object worry about how it gets that information. This hides all that complexity and decouples your code. Now, if the internal structure changes later, you only have to update the user class, not every single place that needs to know a price.
Yes, that is the big aha moment. Once you've gone through these principles, you start to see that they're not just a random checklist of rules. They're all connected. They're all pointing in the same direction, toward one single massive goal.
That's it, exactly. SRP helps us contain change to one place. LSP makes sure our abstractions actually work the way we expect them to. And DIP, ISP, and the law of Demeter, they are all just powerful strategies for managing dependencies. All together, they form a toolkit for building software that can adapt and evolve without breaking.
And really, that's the bottom line. These aren't just things to know for a test. They're practical, everyday tools that every serious developer should have. You need to internalize them, practice them, and let them guide your decisions. They will absolutely, fundamentally improve the code you write. If this breakdown helped you connect the dots on these design principles, do me a favor and share this explainer with a friend or a colleague. And of course, subscribe for more deep dives just like this one. Thanks so much for watching.